Welcome. In this video, we'll take a look at section 5.4, working with the half-angle formulas. So let's take a look at those half-angle formulas first, and then we'll dive into the first example. So we have half-angle formulas for both the sine and the cosine function. So the first one is the sine of a divided by 2. So again, a is some angle. It can be any angle it wants to be. And it's going to be equal to plus or minus the square root of 1 minus cosine A divided by 2. With this plus and minus on the end, this is not telling us that there's two solutions. This is just going to be dependent on what quadrant we are in. We're going to use the plus or the minus for that specific problem. So we have a choice depending on quadrant. So dependent on the quadrant, we will choose the plus or minus. This does not say that there's going to be multiple solutions for these half angles. The two formulas for sine and cosine are very similar. Notice that the only difference here is the cosine has a plus and the sine has a minus. So keep that in mind as we do these problems. The cosine has a cosine inside of it, and so we'll just think of that as the plus, and then the sine changes the function, so you can remember there's a minus inside of the cosine for that sine of a over 2. So let's dive into the first example, and we'll walk through kind of choosing the plus and minus on the outside as we go. So in problem number 1, or the first example, we have the cosine of a is equal to 5 over 3. And we'll go to yellow, with a terminating in the fourth quadrant. So we're in the fourth quadrant, and we'd like to go out and solve for sine of a over 2, cosine of a over 2, and tangent of a over 2. So as always, let's take a look at a picture to start. So if we are in the fourth quadrant and we have a cosine of 5 over 2, or 3, that would have an adjacent side of 3, hypotenuse of 5 for that A angle. This is another 3, 4, 5 triangle, so we'll use that as our opposite side will be negative 4. So this one's nice. It gives us the cosine already to use. And so now all that we have to determine is whether or not this sine of a over 2 or cosine of a over 2 has the plus or the minus sign. So if I considered this angle, a over 2, I want to consider what quadrant this angle is in. So to do that, I'm going to start with the original angle. If I look at angle A, this angle, since it's in the fourth quadrant, goes from 3 pi over 2 to 2 pi. So if I consider dividing that angle by 2, I could divide everything here by 2, divide by 2, and divide by 2. And I could figure out in what quadrant a over 2 will belong to. So a over 2 will be 3 pi over 4, and pi. So this a over 2 angle is going to be trapped between pi and 3 pi fourths. So 3 pi fourths is somewhere in that range. 3 pi fourths. And so here we can notice that the a over 2 angle is going to be in Q2. Q2. And we know something about Q2 and its sign. So we know in Q2 here, the sign is going to be positive, and the cosine function is going to be negative. So that'll be helpful for us when we choose the plus and the minus on the outside. So let's go to work on these next problems, knowing that fact. So when I considered the sine of a over 2, we're going to just use the definition. And we do know that when we look at this plus and minus here, since we are in the second quadrant with a over 2, that would tell us that the sine function is positive. And so we're going to use the positive square root here. 1 minus cosine A over 2. This is nice because we know the cosine of A, so we're going to use that right off the bat. This is the square root of 1 minus 3 over 5, all divided by 2 inside the square root. And we'll just simplify this down. We'll have the square root of 2 over 5 divided by 2. And so this will end up being the square root of 1 over 5. Or we could represent that as 1 over the square root of 5. And for right now, we'll keep that as our solution. The second one we want to go out and solve for is going to be the cosine of A over 2. And so in this one, we know that the cosine is going to be negative in the second quadrant. And so we'll use the negative version of the square root. So this will be negative square root of 1 plus cosine A all over 2. So we know the cosine again is 3 over 5, so we're going to use that. This is going to be equal to negative square root of 1 plus 3 over 5 divided by 2. The numerator here we can simplify, and adding 1 we'll have 5 over 5 plus 3 over 5 is 8 over 5 over 2. And then dividing this 8 over 5 by 2, we can actually cancel out. This is a 4, this is a 1, and so we'll be left with the square root of 4 over 5, or simply we can write it as 2 over the root of 5. All right, so there's our cosine of A over 2. The last thing, we'll actually kind of circle back over here to work out the last piece, which is the tangent of A over 2. The tangent of A over 2, we know it's going to just be the ratio of the sine divided by the cosine. So in this case, the sine divided by the cosine, we'll have the sine is 1 over the root 5 divided by 1 over, or 2 over the root 5. And when you go to simplify this, you'll find that this is going to just be 1/2. So the tangent will be positive here, 1/2. Actually, we'll have a negative there, so sorry. We'll have -2. This should be a negative. That's the mistake. There we go. should be negative since the cosine is negative there. We dropped that negative halfway through, so that is a poor mistake there. So make sure we fix that up there. Shame on me. All right, so there you go. There's the first three half angles there. We've got 1 over the square root of 5, negative 2 over the square root of 5, and then negative 1/2 for the tangent. All right, so let's take a look at another example with this and work another one through. This one we are given the sine of A, and we're given that the angle terminates in quadrant 3. So let's go and build our graph here. I'll try to take up a little less space to work with quadrant 3. So our sine here, make our triangle of this angle that goes through A here. The sine of this angle is negative 12 over 13. So this side will be negative 12. 13. This is also a Pythagorean triple. If you go out and find this one, your opposite side, or adjacent side in this case, is going to be negative 5. So this is found by the Pythagorean theorem. So you'll want to do that as well. So we have 5, 12, 13, one of the Pythagorean triples. And so let's consider now, we know we're going to need to find the cosine of A for each of these problems. So the cosine of A would be, again, our adjacent side, negative 5 divided by the hypotenuse, which is 13. So there's my cosine of A in that quadrant. And so now I'm actually ready to work. We do want to figure out, though, what quadrant our A over 2 angle is. So if I consider A, I'll just do this one in degrees. Since we're in the third quadrant, this is 270, and this is 180. So if my A angle, the original angle in this problem, was between 180 and 270 in quadrant 3, we can divide each of these by 2. Divide by 2. And figure out what quadrant we should be in for A over 2. That would be 90, A over 2, and 135. So this region here, 90 to 135, that is, in fact, in quadrant 2 again. So this means we are in quadrant 2 for my angle, which means, again, that the sine is positive and then cosine is negative. So we'll want to remember that in our second quadrant. So let's consider first finding our sine of A over 2. So the sine of A over 2, again, we know that this is going to be a positive result, so we'll have the square root of, in our formula, again, we're going to be using the sine formula, so that's the square root of 1 minus cosine of A divided by 2. So 1 minus cosine of A all over 2. So we've got the square root of 1 minus the cosine of A we just solved for was negative 5 over 13, all divided by 2. And now we just have to simplify this down just a little bit. We'll have 1 plus 5 over 13. So this will be a double negative inside here. And so when we add 1 and 5/13, you'll find that this is going to be 18 over 13. So we'll have 18 over 13, all divided by 2. So another way we write this would be just 9 over 13. Square root of 9 over 13. Notice that 9 is a perfect square, so we could rewrite this finally as 3 divided by the root of 13. And we'll just leave it as that for right now. 9 over root 13, and that will be positive. We'll take a look at the cosine next. Cosine of a over 2. In this second quadrant again, we're going to be negative, so we're going to take the negative version of the square root. So we'll have 1 plus cosine A all over 2. So the same cosine A is going to be used. So we have negative square root of 1 plus negative 5 over 13 all over 2. If I take a look at the numerator of that radical, 1 minus 5 over 13 will end up getting just 8 over 13. We'll just have 8 over 13 divide by 2. And then if I divide by 2 again down here, we will have 8 divided by 2 is going to be just a 4 there. So we'll have 4 over 13. Or this will happen to be negative 2 over the root of 13 with that perfect square coming out. So since 4 is a perfect square in the numerator, we can pull it out as a positive 2 without the root. So there's our result there for the cosine. And so last but not least, we do need to go out and solve for tangent. And so we know that the tangent can be found by taking the ratio. So we'll take our ratio. If I consider the sine over cosine here, the sine is 3 over the root of 13 divided by negative 2 over the root 13. We wanted to just flip and multiply here. We'd have 3 over root 13 times root 13 over negative 2. Those root 13s will cancel. I'll be left with the result of 3 over negative 2. We can just keep that as an improper fraction there. And we have our sine, cosine, and tangent for the double angles. All right, so that's a second example there, taking a look at just the half angles. The next example, we're going to be combining some concepts from our last section with the double angle and the sum and difference angles as well. So let's consider the information that we're going to be given in this third example. We have a lot of it. So the first thing is that the sine of an angle A is 5 over 13, with A between 90 and 180. The second piece of information we get is that the sine of b is 12 over 13, a different angle, and that is within 0 to 90 degrees. Okay, and so for each of these examples, we want to be pulling on those two angles and their properties. So let's first consider sine of a over 2. So sine of a over 2, we'd like to go out and solve. And so first, we need to work out a little diagram about this angle A. So we'll consider angle A first. We know its sine is 5 over 13 in the second quadrant. So we're going to build a diagram here for angle A in the second quadrant. Its sine is going to be 5 over 13, which means its adjacent side is going to be negative 12. So we have a 5, 12, 13 triangle. And so let's take a look at, again, if I was to do a half angle, if my angle A is in the second quadrant, that means that A over 2 here is in Q1. Right? So if we're in quadrant 2 to begin and we take half of that angle, that means we have to be here in quadrant 1. Therefore, sine of A over 2 is going to be positive. So we know that sine is positive. So we're going to take the positive square root solution for our sine of A over 2. So we know that sine of A over 2 is going to be equal to positive square root of 1 minus cosine of A divided by 2. So same definition that we've been using in the previous examples, we're going to use again here. Now we'd like to go out and solve for what is cosine of A. So the cosine of A, in this picture, we would have the adjacent side, negative 12 over 13. So let's put this together. We have the square root of 1 minus negative 12 over 13 all over 2. So we'll take a look at that equals 1 minus a negative number. We'll have a double negative here again to work with, so this will turn into a positive. So this is really 13 over 13 plus 12 over 13 is going to be 25 over 13. So we have the root of 25 over 13, all divided by 2 in that square root. So one way we can simplify that is the root of 25 divided by 2 times 13. If we divide by 13 and then divide by 2, we'll just be dividing by 26, 2 times 13. Or we could represent that as 5 over the root of 26. If we wanted to rationalize this, we can. So this would be 26 root of 26. And so we'd have 5 roots of 26 over 26. And that would be complete. Part B looks at the cosine of 2b. So let's consider making a sketch of angle B and identifying a few of its properties. Let's bring it on back. We will have angle B. This is going to be in the first quadrant from 0 to 90 degrees. And we're told that the sine of B is 12 over 13. So we have angle B. The sine is 12 over 13, which means this is again a 5, 12, 13 triangle. So the cosine again of B here is equal to, or the cosine of B, yep, is equal to 5 over 13. I'll just jot down the sine as well. So the sine was equal to 12 over 13. That'll be useful later. So let's consider now the cosine of 2b. Cosine of 2b, we can represent it in a number of ways that we've worked with so far. Let's just use one representation. That was 1 minus 2 sine of b. That's one way we can solve this. And that would be squared. So sine squared b. So we know the sine function to be 12 over 13. So we'll just use that right off the bat. This will be 1 minus 2 times 12 over 13 quantity squared. So we've got the following 1 minus 2 times 144 over 169. Or we can continue that process. 1 minus, this is going to be 288 over 169. And then finally, if we put this into a improper fraction and subtract by a 1, you'll find that this is going to be negative 119 all over that same denominator, 169. So we'll keep this as a fraction in its exact form, and that should be our final solution there. So we have a cosine of 2b. The reason why I wanted to write these two cosine and sines out is it'll be helpful for part C here. So notice that we have the cosine and sine of b, we have the cosine of a, and we have the sine of a up at the top. So we have all four of those sine and cosine functions with a and b. This will come in handy in, again, our next problem. So let's take a look now at part C. Part C is going back to our sum angles. So cosine of A plus B. If we recall what our sum angle or sum formula here is for the cosine, when we're working with cosines, we always want to do start with the cosine of both angles. So that's cosine of A, cosine of B. And since this is a plus sign, we'll put in a minus sign in between. So it's the opposite sign of sine A, sine B. So that's our cosine sum of A plus B. So let's consider now putting in the information we know. We know the cosine of both angles, so let's take a look at that. We know cosine of A is negative 12 over 13, cosine of B is 5 over 13. So we'll have negative 12 and then 5 over 13. minus the sine of A, we knew to begin with was 5 over 13. And then our cosine of B, our sine of B is 12 over 13. So a lot of the same values there, but negative. And we'll finish this one off. We have negative 60 over 169, and then minus, again, 60 again, over 169. So this will become negative 120 over 169. So that one looks great. Let's take a look at the sine of A minus B. So the sine of A minus B, whenever we work with sines, we're always going to have the sine of A cosine of the other angle B, and then we'll do the opposite, which is the sine of B, and then the cosine of A. And again, here we have a minus sign in between with this. And so for the sine function, we keep the sign the same. So this would have a minus sign in between for the sine of A minus B. And again, we know all of these components. We just have to put them in the right order. So sine of A, 5 over 13. Cosine of B, we know is again 5 over 13, minus sine of B, 12 over 13. And then the last is cosine of A, which for us was negative 12 over 13. So we'll have a double negative there on the back half of this problem. So this will be a double negative. And so we'll have 25 over 169 plus 144 over 169. If we add those two together, this happens to add to exactly 1. And so we have that one, exactly 1. And we'll finish up this video with one more example using the half angle formula. The last example here that we'll take a look at uses the half angle formula to find the exact value for sine of 105. So let's consider first the angle of 105 degrees. And then we'll use the half angle formulas to solve its exact solution. So the first thing is, where is 105? 105 degrees is sitting in the second quadrant, in Q2. And so when I think about Q2, the sine of a quadrant 2 angle is positive. So we know we're going to be taking the positive square root in our formula for the sine of 105. So another way we can rewrite this expression is I'm taking the sine of, well, double this angle would be 210 over 2. And again, we're taking the sine of A over 2. If this is representing sine of A over 2, again, that A angle that we're working with is 210 degrees. And so I'd like to know, for this calculation, sine of A over 2, we know that this is defined as the square root of 1 minus cosine of A divided by 2. So what I need to go out and find is really the cosine of 210 degrees. So let's go out and find the cosine of 210 degrees. 210 degrees we know is in the third quadrant. So let's consider the third quadrant with the angle of 210. This forms a familiar 30, 60, 90 triangle. And so if I consider that unit circle, we have one, or really if we do the 2, 1, and square root of 3, this will be even nicer. The ratios of our 30, 60, 90 triangle. We know that the cosine of this angle is going to be -1, or -1 over 2, which is our hypotenuse. -1 over 2 is the sine, and the cosine, excuse me, is going to be our adjacent -√3 over 2. So we'll have -√3 over 2 for that one, for the cosine of 210. So really no need to really look it up in the unit circle. We can just draw our reference triangle in that quadrant and work out what the cosine is. So let's use that to our advantage. We know our cosine of our A angle. So we'll begin with 1 minus square root of 3 over 2, divide by 2. So we'll have double negative here to work with. So we'll just have this we can represent here with a 2 over 2 plus √3 over 2, all divided by 2. And so if I divide both of those two fractions by 2, we can take a look at a way to represent that. We have in the numerator, this has 2 plus the root of 3 all over the common denominator of 2. And we're again dividing that whole thing by 2 again with this 2 right there. And then one more step here, we can take 2 plus the root of 3. If we divide by 2 twice, we're really dividing by 4 there. And so one more way we could write that is the square root of 2 plus the root of 3 inside, all divided by 2 outside that root. And that would be our sine of A over 2, where our A angle is 21. So this is going to be the exact solution for my sine of 105 degrees. All right. So hope this is helpful with working with all these half angles, and then a little bit of review for the sum and difference angles and the double angles. You can check out these notes and solutions on our WebEx page, or the More page. And I hope to see you in the next video. Thanks for watching.